All right, welcome everyone. Today we're gonna take a quick look. Not quick. We gotta take a look at the 1.47 patch notes for Rustlang. They came out about a week ago, last week, Thursday. Haven't really had like a chance to go through them like in depth to try everything out. So I figured let's make a video and go through them together. So I know I've seen like a few things, but like, you know, it's more fun when you actually like understand every single thing that's like changed, and then, you know, we can move from there. Yeah. Did that sentence make sense? Maybe. Who knows? Who cares? Let's dig in. All right. So here on the left hand side, you can see the patch notes. Oops. Let me increase the font size slightly. As usual. Same old, same good stuff. Rust up, update stable. Gives you the most recent Rust version. In this case, we have the playground open on the right-hand side, so we can test features out. We're on 1.47, so that's nice and easy. All right, so what's new? Traits on larger arrays. Rust does not currently have a way to be generic over integer values. This has long caused problems with arrays because arrays have an integer as part of the type, tn. It's type of the array of tn length. So this is const event stuff, which is quite nice. Because there is no way to be generic over n, you have to manually implement traits for arrays for every n you want to support. For a standard library, it was decided to support up to n of 32. So yes. We've been working on a feature called const generics that allows you to be generic over n. There's a lot of stuff in there, which is nice, great. But now you can print this. Okay, let's try this out. Oh, how does? All right, let's just type it out. All right, so now we can define an array. So in Rust, arrays are different from vectors. Arrays live on the stack. Vectors live on the heap. They're heap allocated. So in this case, we can create something on the stack. 0, 34. This will initialize an array of 34 zeros and XS. And then if we compile this, we get 34 zeros instead of like a compiler. Very nice. Like, not a big change, but all this really does is just enable something that you kind of would assume that would work anyway. Having that restriction lifted is really nice. I believe cryptography people really like this because they can just compact all sorts of stuff, probably AI kind of things. People that work with numbers a lot will be probably into this since things will just work better. Okay, great. Shorter backtraces. Cool. So before this, we had like very elaborate backtraces. And now if we panic, it should be the briefest backtrace possible. Thread main panicked, explicit panic. All right. If we expand this, we'll likely get a whole bunch more. There we go. Function call once. Say we have function foo, which calls bar. And then function bar, which panics. And then here, we call foo. Then this should just very nicely tell us, wait, hold on. We need to disable the backtrace, disabled. Try again. Thread main panic, explicit panic, source main 10, 5. There. Oh, interesting. I would have sort of like expected us to like get the full backtrace, but all we got was like this really. So it is a bit nicer. All right. So this is the old backtrace, thread main panic, explicit panic, and then like all this stuff. And now all we get is this. Oh, okay. If we print full backtrace, otherwise we don't. We get the super short one. Interesting. Okay, that's kind of neat. So if we say like, hey, give me the full backtrace, then we get the full one, which is just like the important lines. Okay, this is really good. There we go. And then we can say, oh, enabled, not full. All right. Oh, and with full, we get like the full backtrace still. Great. Yeah, so as you can see, if you enable the backtrace, all you get is like the relevant lines. And if you don't enable it, all you get is like the location of the panic. That's really good. That's nice. I dig this. This is really good. All right, cool. That's new in this version. That's actually a pretty big deal. Like being able to debug panics faster is actually really good. I think this may have been the case before, but not necessarily. I forget. It's good though. Like short backtraces is very convenient. It used to be like really hard to like find exactly where a backtrace came from. All right, next point. LVM 11. We've upgraded to LVM 11. The compiler still supports being compiled with LVM versions as old as 8, but by default 11's what you'll be getting. Okay, that's nice. One bug this fixes is, do I know? Can I find it? All right, so this fixes one specific bug where on Windows systems, like just upgrading LVM actually fixes a miscompilation where on Windows systems there was something about like LVM instructions not being able to be found in certain cases when compiling async await. Upgrading to LVM 11 has solved this for everyone. So LVM 11 is fantastic. Great. I'm personally very happy about that just because it fixed like a bug that we were running into at work. So that's good stuff. All right, next highlight in the patch notes. Control-flow guard on Windows. Rust C now supports C control-flow guard, an option that will turn on control-flow guard on Windows. I believe Microsoft contributed this patch, which is really nice. I believe they're like using Windows to more capacity, and this was a thing they really wanted because this what does it do? It protects against like vulnerabilities by checking pointers or something. Control-flow guard is a CFG, is a highly optimized platform security feature that was created to combat memory corruption vulnerabilities by placing tight restrictions on where an application can execute code from. It makes it much harder for exploits to execute arbitrary code through vulnerabilities such as buffer overflows. Yeah, so this is really nice. It essentially does what I just said it does, which is it checks that a pointer is within a valid memory range, and if it isn't, it will crash the program and simply not allow it. And like that is still very relevant for Rust, given like how many C libraries are linked into Rust, how much C Rust talks to, even like unsafe in Rust, Windows has this capability for a good reason, having it in Rust disabled by default, but having a flag to just enable it, I can imagine if you're a Windows dev, that's quite nice. Yeah, so that's it for the major features. Rust 1.47. Now for the smaller, I guess, library additions. So ident new raw. All right, so there's a proc macro thing, and there's ident new. So an ident in a proc macro is just a thing. I believe like the best description is it's a thing that's pointing to an object, an identifier. Here we say ident new, which gives us stir and a span. All right, ident new raw is new in 1.47. Same as ident new, but creates a raw identifier. The string argument to be a valid identifier permitted by language, include fn, etc., etc. Okay, cool. So, fn main, say we wanted to use try. I believe we need to do r hash try to do something. Yeah. So try in Rust 2018, for example, is a keyword, same as async. In order to use outdated keywords, old keywords that have since in a newer edition that you opt into become reserved, you can still use the raw identifier syntax to refer to them, which is really nice. This is really nice. So this just internally, if you're writing procedural macros, which is like a compiler hook kind of thing, is the best explanation I got. You can now create raw identifiers directly. That's great. Cool. I guess slowly we're like working up to better proc macros, which is exciting. Ooh. I had dinner not too long ago. All right, range is empty. We're gonna keep that one open. I'll put that one over there. So range is empty. Returns true if the range contains no items. Cool. Oh, we can just click run on this, put that over there. And then we run this. And then we see that all of these ranges are empty. So here we say, oh, that's confusing. Not 3.5 is empty. Actually, what does that print? What does that print? For not 3.5 is empty. Oh, this means this is full. Okay. Okay, we truly need Scala's is non-empty. They have a special one for that, which is actually quite good. So yeah, so this contains values, which makes sense. 3.3 doesn't iterate at all. It's empty. 3.2, this always counts up. So 3 to 2, 2 is lower than 3, so like yield nothing. That's it. Same. All right, that makes sense. Cool. Range inclusive is empty. Same as that. So 3.5. Well, same as that, but this counts. Yeah, if you count 3, 4. 3 dot equals 3. Debug num. Right. This will just print nothing. Num equals 3? Oh. Oh yeah, there we go. Yeah, so this is actually contains items. There we go. I missed the bang there. All right, cool. But then this will not. Okay, there we go. Is empty. Okay. Yep, that makes sense. Range inclusive. Great. Cool. Result as the ref mute. Now that's going to be an interesting one. So this converts from result TE or nmute result TE to result nmute T as the ref mute target nmute E. Oh, that's neat. Okay, what's the example here? So this is from conversion for references inside of a result. If we look at Rust as the ref mute. Oh, apparently it already existed for option, or is that new for option as well? No, they already existed for option as the ref mute. When was that added for option? 1.40. Interesting. Okay, so now we get it for result as well. So this is the example. We're just going to copy paste it. Tools, Rust format. So it actually looks decent. Run. And this just works. Okay. So what do we got? We have a string called hello, just containing hello, allocated on a heap. And then we get a result of a string here. Okay, that makes sense. And then y and mute s. Okay, this then gets a reference to the original string, which gives us y, which is now result mute stir. Okay. And then we say x dot as the ref mute map x dot make ASCII uppercase. What is the type of x here? Is that the type of nstir? No, nmute stir. Is that so? Yeah. Nmute mute stir. So as the ref mute, we'll go through here, convert that into a reference. And x dot make ASCII uppercase, and then we can iterate over it, and that should be equal to y over there. All right, I kind of get it. It's a bit convoluted, but sure. X dot make ASCII uppercase. Yeah, this example is like kind of out there, but I can see like x dot as the ref mute being like really nice. in some cases where you like need to get a reference, like a mutable reference to something, through a result, but you don't want to handle the result, because the alternative is like going through and trying to handle the result, or like doing some odd kind of mapping. Probably if we look at the implementation, it's rather straightforward. Yeah, there we go. As deref mute, self.asMute.map t.deref mute. And this just like replaces this little indentation with something much, much shorter. Yeah, that's nice. So no more t.deref mute, but instead this. I bet like a clippy lint or something will probably come into existence at some point and like start suggesting to use this instead of like the little incantation that we're seeing here. Yeah, x.asDeref mute versus self.asMute or x. Yeah, so the equivalent would have been, let me just type it out. Assert eq x.asMute.map t.deref mute, I guess, and then .map again. Is that, am I one map too deep? No, I'm one map, correct. .map x x.make ASCII uppercase x, and then here we put in y, and then we complete that there. T.deref mute for mutable reference. Whew, how does that work? X.asDeref mute. Oh my god, this is much worse. Map t .map x. Am I right? No, x.asMute .map t. Oh, yeah. .map x x.deref mute .map x. I don't know. Oh, yeah. We just need to do use stud ops deref mute. There we go. So in order to use this method, that needs to exist. Found mutable reference. There's an associate function with a similar make ASCII uppercase. Did I mistypo that? There we go. Yeah, I typoed that. Anyway, these two things are equivalent. This much, like the Neo method's much better. Even though this is hyper niche, Clippy will most likely help here. All right, cool. Cool. Result as the ref is the exact same, but instead of mutable, it's just like a reference. Great. What else we got? We have, let's clear this out. Oh no. Great. Okay, we have vec leak. Closing, vec leak. So this consumes and leaks a vec, returning a mutable reference to contents. Note that the type T must outlive the chosen lifetime A. If the type has only static references or not at all, then this may be chosen to be static. This function is similar to a leak function on box. This function is mainly useful for data lives for the remainder of program's life. Dropping a return reference will cause a memory leak. Ooh. Okay, so we call leak on it, and then we get a static reference to a thing. Oh, that's interesting. Oh, that is fantastic. Box leak self into box slice. Oh, that's so cool. Okay. Wait, hold on. I need to find the right words to explain this. We have that, and then we're gonna tools, rest format, come on. Yeah. Okay, good. All right. So what this does is the static lifetime in Rust essentially says like this. Oh wait, am I right? No, I'm wrong. Wait, hold on. What does this do? Static graph assert equals static graph to be static. Box leak. Interesting. Type T must outlive the chosen lifetime A. All right. Okay. So my interpretation of this is you have you want to construct a type that then lives forever, right? So you can imagine something like lazy static, which is pretty common. Like if you look here, then for example, we create a static ref, right, with a hash map that we then like initialize during runtime. So first time this is called, this is initialized, this code is run exactly once, and then we forever have a hash map, right? This feels very similar to that, where we construct a type, we fill in every single param to it, and then we convert it into a thing that now just lives forever. The data never gets deallocated, and we get back, I guess it's mutable, but it does live forever. Interesting. So yeah, it doesn't go away. I believe lazy static can still be mutated, so I'm not too sure. .get. Oh yeah, there's like a thing in there. I don't know. I don't know when I would use this, like specifically. My guess is like if we look in the corresponding thing, we'll see like actual use case for it, but dropping the returned reference will cause a memory leak. Yeah. It's interesting to say leak. I've never like used leak on box, but I can see it being useful if you like just want to keep it around and like dropping it won't like deallocate it. That's good. The short version is like it's a shorthand to not have to write this, but you know. Cool. Pointer offset from. So calculates the distance between two pointers. The return value is in units of t. The distance in bytes is divided by mem size of t. This function is the inverse of offset. Okay, now this is risky, and I don't know enough about pointers in Rust, or pointers like in general, to make like any assurances about it. So like tread careful and like please reread this. I'm reading it for the first time, as probably you may be also. So what this does is, okay, we have one pointer here. So example here, right? We have one pointer, we create an array on the stack here. We define a pointer in the second slot and in the fourth slot, and then pointer offset 2 from pointer 1 is 2. Let's just copy this again, or just hit the run button. Interesting. Okay, so that works. Pointer 2 is 2 spaces from there. Does that make sense? It returns 2. This one's 2 spaces from there, 2 bytes from there. So -2, pointer.offset 2, pointer 2. Interesting. Okay. If we offset from, and then we have the offset method also. Oh, whoops. Offset here calculates the offset from a pointer, and then we get back a MUT print line. This is wild. Oh, amazing. Yeah, hold on. If we then run this, I bet this is fun. Yeah. This essentially says like, hey, we have a pointer right here. So the first location, and like, let's get 1 byte over, or like, let's get 2 bytes over. And then it just gets us over there. It's fascinating. And here, this is the relative version of it, where we have a pointer, and we calculate the distance from the other one, and we get the inverse. We say like, oh, it is that many spaces over. How's this implemented? Okay, cool. So that's offset, and then we have offset from, wrapping offset. Oh my God. Pointer arithmetic. Okay, so there's intrinsic offset. And wait, hold on, that's offset twice. Offset from unsafe, self constef, offset from origin. Is there multiple offset froms? Offset from pointer offset from core intrinsics. Yeah, that makes sense. All right, so apparently there's a, intrinsic just for get a pointer offset from something. That makes sense. Intrinsic here, by the way, means there's a mapping for this in LVM somewhere. And depending on like the backend, there may even like be instructions for this, or LVM knows how to compile down to a set of instructions or optimize it away. There's like multiple levels of that. So yeah, this just means it's down to like a single thing that lives somewhere in the backend of the compiler. Cool. Next up, F32 tau. This is 2 pi as a constant. That's nice. I feel this should also link to pi because we have that. Archimedes constant. Yeah, okay, great. Cool. Now we have a bunch of them. The square root of 2 because we don't want to keep calculating that apparently. What else do we have in there? I've never even looked into this. Euler's number, frac 1 pi 2, variety of frac pi numbers, log 2 10, log 2 e. Yeah, makes sense. That's all reasonable. I don't do like enough math to like fully understand what's going on there, but I have seen numbers like that at some point during high school, and I get it. All right, great. The following previously stabilized APIs have now been made const. Oh, great. So we have non-zero during const. That's fun. Checked add, checked sub, checked mul, all the mathematics stuff. Oh, that's nice. Make more primitive integers const. Oh, is this the same PR? That's just the same PR. Yeah, 73858. 73858. All right, so this just went over like a whole bunch of like const stuff. Amazing. And this was made possible because const if match. Okay, that's good news all around. Great. Other changes. Rustock now has a new theme. Let's take a quick peek what that theme is. Oh, it's nice and blue. That's kind of cool. Cool, blue Rustock with like very fancy yellow lettering. Not really my thing, but choice is nice. What else? Detailed release notes. What else is new here? There we go. Cool. So we can close that out. Now we're going to dive into the slightly deeper patch notes. Closures will now warn when not used. Alright. So warn about unused expressions with closure or generator type. This follows existing precedents of must-use annotations present on fn once, fn mute, fn traits, which already indirectly apply to closures in some cases. All right, this makes sense. So that's just like a no-up closure that's never called. It's not even passed to anything, which means it was probably a bug. That makes sense. Okay, cool. You know what? For like a next version of this, I should just like go over like these patch notes. I bet that's like a bit more, like fewer people read this and they're a bit more, in depth. With the other things like being good illustrative examples. Cool. Control flow guard. That's good. Upgrade to LVM, etc. add tier 3 support for a new target. I think this is an embedded thing. Oh, what? Okay, so you can now compile Rust for the Game Boy Advance. That's pretty sweet. Okay. So, for those of you who don't know, Rust has tier support for a variety of platforms. Essentially what that means is some platforms just exist in tree, and Rust promises not really to support them. Then there's a stage where they get a bit better support. I don't know exactly the assurances there. There should be a forged Rustlang org. Should have documentation on them, I believe. But basically tier 1 support means this is like a prime target. We guarantee this will work. For example, Windows or Mac OS, like Windows 10, Mac OS, etc. They're like tier 1 supported targets. But then, for example, recently, like 32-bit Mac OS got, like, Apple was like, we're no longer going to support this. And so Rust had to actually demote it from a tier 1 to a, believe, tier 2 target. Because it's like, well, Apple won't, support this anymore, so we can't either. And that's just the tier support. This got moved into tier 3, which means you can probably use it. Just the compiler will not promise to, and it's effectively reliant on external contributor support to make this work. But still, really cool. Rust on PSP, Rust on Game Boy Advance. I think that's pretty neat. All right, what else? Upgrade the FreeBSD toolchain to 11.4. Oh, nice. Cool. Okay, this just enables the newer FreeBSD. Oh, there we go. More information on support. Here we go. Tier 1, Tier 2, guaranteed to build. And then Tier 3 is, it exists, but they're not tested and may not work. Yeah, that makes sense. Cool. CStir now implements index range from usize. This change implements partial slicing for CStir. Let me up the font size. That's a bit more readable. Since the CStir must end in a null byte, it's impossible to trim from the right and still have that CStir, but it is possible to trim from the left. This lets us be a bit more flexible and treat it more like strings. CStir from bytes with null. All right. That's interesting. Okay, so this is like a partial index method that panics in some cases. Index start, bytes length. Okay, no. That's valid. Index from empty, from byte null. Okay. Interesting. Index ops range from usize. Okay. So what this does is implement, this only adds literally the syntax for this one in order to do the right hand side. So say like we have a meister and we do .6 where we say like get from the start up until 6. We would have needed to implement ops index for ops range 2 stood ops range 2. There we go, and that's the right hand side. End. There we go. Cool. So it only implements the left hand side for null terminated strings because those have null on the right hand side. So we can like trim from the left up until the end. All right, that makes sense. That's nice. It's just a nice little ergonomics improvement. I get it. Sweet. Traits in stirred core are now implemented for any length, not just length of less than 33. That's the one we looked at earlier. That's the, for the array stuff. Ops range full and ops range now implement default. What's that? Range and friends can probably can implement default, for example, IDX default. So if we have a foo that has a range inclusive inside of it, which is a struct, and then we get default from it. What? Wait, hold on. This is interesting. A 2-line patch just implements a default trait. So if the value inside of it .get core ops range default. What's the default range? Core ops range default. Range. Core ops range. And this implements default. And default for range is whatever's inside of it. Index. So default there, IDX. All right, so it just passes through the generic argument. So if default exists on the default, then it passes it through. Essentially what this means is it implements default if default is implemented on the inner thing. Okay, cool. That makes sense. No reason not to have that, I guess. Panic location implements copy clone equal hash or partial equal and partial ORed. Wonder what the use case for that is, but I guess it makes sense. Oh, cool. Adam. Now track caller is on track to stabilize. One of the roughest edges of working with is the fact that you can do much with location except turn it back into a stir U32, which makes sense because the type was defined around the panic machinery, originally passing around that tuple. Common traits for a type in accordance with the API guidelines. Cool. Okay. Oh, yeah, cool. That makes sense. And this now just derives those impls. Location, derive. All right, cool. Now it just implements all these types, which seems decent. All right, cool. That's not important, but you know, that I guess that's why it's like in these patch notes. What else is new in the ident new raw? Range is empty, range inclusive, vec leak, etc. We've seen that. Oh. Build dependencies are now built with op level 0 by default. You can override this by setting the following in your cargo toml. Oh, that makes sense. So if you have a build dependency, just something that runs during compilation, it's not, people are not trying to optimize it. It's essentially saying like optimize for speed, like compilation speed, right, and end user performance. Which makes sense. Whether or not that always ends up being the case is questionable, but you know, the intent makes sense, I think. Cargo help will now display man pages for commands rather than just the help text. Oh, man page support. That's nice. I wrote this crate several years ago. The man crate. When was this published? So you can like use a builder to build stuff. Yeah, June 2018. One of my first little projects. To display a man page for the given command, cargo command help continues to show the basic clap output. Oh, that's nice. Does it use the clap man? It doesn't. Oh well. Cool. That's nice. Cool. Workspace default members now respects workspace exclude. That makes sense. Oh, it's a good one. Cargo metadata now emits a test field indicating if a target has tests enabled. I've never used cargo metadata. What is that? Cargo dash metadata. Ollie made this. Where tests should be run for a target. Okay. And that just forwards stuff. Okay. Sure. Okay. Oh, cool. Expose where bin lib target is test enabled. And this ends up being used for MIDI, which is cargo mirror test ignores test equals false. All right, cool. So in order for mirror to respect whether or not like a target has test enabled and should like be even like checking those test files. Cargo, like Cargo's internals had to expose it to go through cargo-metadata to eventually end up in Meaty. Oh, nice to know. Where Meaty is a Rust runtime, what do you call it? Interpreter. Sorry. Cargo publish will now use an alternative registry by default if it's the only registry specified in package.publish. Okay, I haven't seen package.publish before. Failing, we're defaulting to be to the only allowed registry, yada yada yada. Okay, nice. So it just configures cargo stuff. Okay, compat notes. Bumped minimum support mscripting version, which is nice for mscripting users. Fix the regression parsing empty blocks and false in tail expressions. That seems interesting. Added changes to how proc macros are expanded in macro rules. Preserve more span information. Okay, so barrier diagnostics, I guess, can be generated in how proc macros now work. Move support for the cloud ABI target to tier 3. Is that a demotion? Did that go from tier 2 to tier 3? Was that a tier 2 previously? Yeah, it's higher up on the list next to FreeBSD. Okay. That means Cloud ABI is funny. Cloud ABI was published by a company called Wasmer as an attempt to specify like a system standard. And a couple months later, I believe, less than 6 months, maybe 9 months, I don't remember. Effectively, a full consortium, like I believe, just started working together on something that wasn't that. And yeah, we're now seeing the fallout of that, where effectively Cloud ABI seems to have been abandoned, and everyone's like full in on WASI, the WebAssembly system interface, and it makes sense. Like, yeah, WebAssembly is not just for the quote-unquote cloud, even if like some startup wants it to be. I don't like the Wasmer people too much. This is interesting. All right. Linux new targets now require minimum kernel 2632 glib C. Okay, some version. Add a Rust docs component. This allows you to install and read the documentation for compiler internal APIs. Oh, that's interesting. Previously, it was listed as a package, but wasn't available in component lists. Rust C docs, current CI. I wonder what this is. Okay, Rust C docs. So just the internal docs that you can like look at. Okay, I guess that's nice. Internal only improved default settings for bootstrapping in x.py. Okay, cool. Sure. Okay, that's nice. Interesting. I didn't like read the 146 patch notes in depth, which I guess is fine. But yeah, it's all like interesting stuff. Is there anything else? No, I don't think so. I mean, I guess that's Rust 1.47. Hope it's interesting. I might try and do one of these again for like 1.48. I should have a few patches landing in that one, so maybe I can like share some more details exactly what's going on in there. Yeah. Thanks so much for watching. Like, subscribe, hit the bell if you like. Follow me on Twitter, maybe. I don't know. I don't really care. Thanks for your time. Have a wonderful day.